In this explainer, we're going to break down the core concepts you need to develop robust, production-ready applications with FastAPI. So here's how we're going to tackle this. We'll start at the very heart of a FastAPI app, the individual endpoint, and then we'll zoom out layer by layer to look at the bigger, more global concerns. Think of it as building from the inside out. Okay, let's get right into it. The absolute foundation, the atomic unit of any FastAPI application, is what's called a path operation. You probably know it simply as an endpoint. This is the specific function that handles a request for a given URL. And here's what that looks like in its most minimal form. It's surprisingly simple, right? All you're really doing is taking a standard Python async function and putting a decorator on top of it. And believe it or not, this little snippet here, that's a complete working API. So let's break this down into its three essential pieces. First, you've got the decorator, at app.get//. This is the part that tells FastAPI, hey, when you see an HTTP GET request for the main root URL, run this function. Second is the async function itself, read root. This is where your actual business logic lives. And third, the return value. You can see we're just returning a Python dictionary, but FastAPI is smart enough to automatically convert that into a proper JSON response for you. Okay, so we've got an endpoint. That's a great start. But of course, APIs aren't just about saying hello world. They're about moving data around. And that brings us to a really critical piece of the puzzle. How do we manage and, more importantly, validate all the data that's flowing through these endpoints? And this is a universal problem, right? For any API you build, you have to answer this question. How can you be absolutely sure the data you're getting is what you expect it to be? Because without that guarantee, your application is just wide open to all kinds of errors and malformed data. Well, FastAPI has a really elegant solution for this. It's deeply integrated with a library called Pydantic. What it does is leverage Python's own type annotations, those type hints you're probably already using to define the exact shape, type, and constraints of your data. This creates an automatic, powerful layer of validation without you having to write a ton of boilerplate code. And this comparison shows you just how big of a deal that is. Look at the code on the left. If you just accept a generic dictionary, it's on you to manually check if the name key exists, if it's a string, if price is a number. It's a lot of tedious work. But now look at the right. By simply type hinting that item is of type item, our Pydantic model, FastAPI does all of that work for you. It parses the JSON, it validates the fields, and it even gives you a nice, clean item object to work with in your code. It's a real game changer. So the benefits here are huge. You get automatic data validation, both coming in and going out. You get type safety. If someone sends bad data, FastAPI automatically sends back a super detailed JSON error message telling them exactly what's wrong. And maybe one of the best parts, it uses these same Pydantic models to generate your interactive API documentation for you. It's incredible. All right, so Pydantic is fantastic for handling the data for a single endpoint. But what about logic that you need to reuse all over the place? I'm talking about things like connecting to a database or checking if a user is authenticated. You definitely don't want to be copying and pasting that code into every single path operation. That's a maintenance nightmare waiting to happen. FastAPI's answer to this is a really powerful and flexible dependency injection system. The core idea is simple. Your endpoint function just declares what it needs. It says, I need a database session, or I need the current authenticated user. Then FastAPI's engine figures out how to create and provide that resource when the endpoint is called. And this approach is just so effective for keeping your code clean and centralized. Instead of manually creating a database connection and passing it around through function calls, you just ask for it as a dependency. Need to know who the logged-in user is? Just inject that dependency. It lets your actual endpoint code focus only on its specific business logic. So how do you make one of these dependencies? Well, it's just a regular Python function. It can even take parameters, just like a path operation can. You can see in this example, the common parameters function is set up to handle some common query parameters, like queue for a search query and skip and limit for pagination. Okay, so you've written your dependency function. How do you use it? You use this special object from FastAPI called depends. You put it right in the signature of your path operation. By saying commons dict equals depends, common parameters, you're telling FastAPI, before you run my read items function, I need you to first run common parameters, get its result, and give it to me in this commons variable. And just like that, that logic is now completely reusable. Now, it's really important to get the distinction here. Dependency injection is for logic that some endpoints need. They have to specifically ask for it. But what if you have logic that needs to run on every single request that hits your application? No exceptions? That's where middleware comes in. Think of it as a global gatekeeper for your entire API. And just like with path operations, FastAPI gives you a simple decorator to create middleware. You just write an async function and decorate it with @app.middleware_HTTP. This function now gets to sit in the middle, able to inspect and even modify every single request coming in and every response going out. Now, the flow here is really the key thing to understand. The middleware acts like a wrapper around your endpoint logic. First, the request hits your middleware. You can do whatever you need to, maybe add a header, log something, and then you must call callNextRequest to pass it along to the actual path operation. Once the endpoint is done and creates a response, that response travels back up through the middleware on its way out, which gives you one last chance to modify it. It's a very powerful pattern. Okay, last but definitely not least, let's talk about security. Obviously, for any real-world application, this is a non-negotiable, absolutely critical piece of the architecture. One of the smartest design decisions in FastAPI is that its security tools aren't some custom proprietary invention. They are built directly on top of the OpenAPI specification, which you might know by its old name, Swagger. And that matters because it means your security setup is standardized, it will work with tons of existing tools, and just like with Pydantic, your security schemes get documented automatically. So this table shows you the main security schemes that OpenAPI defines. You've got your basic API keys, standard HTTP auth like bearer tokens, and even complex flows like OAuth 2. The great thing is, FastAPI gives you helper classes for all of these in its FastAPI.security module, which makes setting them up so much easier. But here's the really elegant part. How do you apply these schemes to an endpoint? You use the exact same dependency injection system we just covered. It's a beautifully consistent design. So when you put all these pieces together, the path operations, the Pydantic models for data, dependency injection for shared logic, middleware for global actions, and the standard-based security tools, you have a complete toolkit. But it leaves us with a fundamental design question. As you build a larger application, how do you decide what logic belongs globally in middleware versus what should be a more specific dependency? This is a core architectural decision, and getting it right is what will ultimately determine how scalable and how maintainable your API truly is.